Oh yeah, there we go. Alright. So this is a center tap transformer. It's small. It's not a line voltage type transformer. But here it is. You got a center tap. This would be your L1, L2. Alright. So if I plug this thing in, turned on, got my center tap here, and from here to here I'm going to have like 7 volts, and from here to here I'm going to have 7 volts, but here to here I'm going to have 14 volts. This is center tap. Now let me show you about how it would go on a ground if it was on a pole, for instance. Okay, so I got this plug. Don't worry, the hot is broken off. It's safe for what I'm doing. I've used it for a long time. So you got this ground. I'm going to connect this ground to the center tap. Alright, with my trusty old Radio Shack meter here, go L1 to L2. Got 14.67 volts. Alright. Now, if I just take one off L1 and go to this ground connection, which is this right here, showed you that plug there, I got 7.34. If I move over here, this one, I got 7.34, 7.35. There it is. Okay. So again, back to these. If I go back here, I got 14.69. Now the center tap here, for this transformer, this is an old Radio Shack transformer. Now this thing was made back when the line voltage was probably still 110, 115 volts. It was lower because this is rated 6.3 and 6.3. So 6.3 to here, 6.3 to here to here. Okay, but you're actually seeing over 7 volts. That's because the line voltage now is 125 volts typically. This transformer also has a amperage rating rather than a kilovolt amp rating. But anyways, so maybe this may help you understand. This would be your high voltage line, you know, right here, coming in from the power company. And this would be their transformer on the pole, and you know, you'd be 120 volts here to here and 120 here to here, and this would be your neutral, which is bonded to your ground. So you'd have a ground rod. If you was going to your meter, you have a ground rod, and your ground would be tied to this neutral at your meter, as well as the power company would have a ground, like it's set up here, would have a ground off of their transformer. Now this transformer, if you're running it in a circuit, let's say if we disconnect the ground, so you've got 14.7, and here you got 7.3, and here to here you got 7.3. Okay, so you don't have to, this particular one, you don't have to have it connected to a ground for it to function properly. And that's because the way these transformers are wound. This one is wound different than, say, your distribution transformer. This is one phase, and a distribution transformer is 180 degrees out from each other on your secondary. Anyways, this video came about, I was seeing on social media, a guy was using some batteries to demonstrate a center tap. But I mean, I guess you could draw it, but this is pretty easy to understand. Now I could also go back here to here, and I could take this center tap and stick it on the neutral here. Say that would be like putting it on the power company's neutral and ground. So I'm still at 14.79. Take it off. It's still the same thing. Additionally, I can tie one to the center tap there and then take a ground to the other one, and there's no change. It's because of the different windings. Now, maybe explain that in a different video. But the principle is the same. The center tap, it's half. But you can tie this to ground if you're using it, say, in an electronics application. Some applications would actually, you would probably want to bond perhaps this to the frame or something with a your neutral or ground or whatever. Just depends on the circuit, really. But that's what this transformer is made for. And again, I don't know if I said this a second ago, this would be one hot in your electrical panel. This would be your other hot in the electrical panel. And this would be your neutral. The white. What you tape white, whatever. Alright, thanks for watching.